Welcome to Frequency Matters, the RF and microwave update. We have a special episode today as we talk with Greg Henderson, Vice President of the RF and microwave business at Analog Devices. Welcome to the show, Greg.
Thanks for having me, Pat.
We go back to the MACOM days, a mobile radio group that was bought by Harris Corporation. Maybe you can tell us a little bit about your background and what your responsibilities are at ADI.
Yeah, so I've been in the RF and microwave industry since the mid-90s. Actually, at MACOM, I started in their semiconductor business, in the R&D group for the semiconductor business. So I've spent about half my career in RF and microwave semiconductors at MACOM, TriQuint, and now at what was Hittite through Analog Devices. Also spent about 10 years in the radio business, as you said, for what was MACOM, Tyco Electronics, and Harris.
So you've made the rounds like a lot of people.
Made the rounds like a lot of people, yeah, exactly.
And so at ADI, what is your responsibility there?
So I came to ADI through the acquisition of Hittite, and at Hittite I was running the RF and microwave business. Now at ADI I run the RF and microwave business for ADI, which is kind of a combined entity of what was the Hittite RF and microwave business and what was the ADI RF business that we've integrated together as a single entity.
Yeah, with that acquisition of Hittite, ADI just really has a broad range of products now, from bits to the antenna, right?
Yeah, I think what's great is that, you know, through this combined capability, ADI has really strong from data converters up through the antenna, and we're able to do integrated signal chains for the target markets that we're in. This gives us a real opportunity to provide optimal levels of integration to our customers. Because we have these complete signal chains and the technologies that go through the complete signal chain, we're able to provide optimal integration levels.
Great. Gary and I visited you and we saw the mmWave labs, which were very impressive. So thought maybe we'd focus a little bit on the mmWave products. What kind of capabilities and unique things do you bring to the market there?
Yeah, so we have a big focus actually in microwave and mmWave solutions. We have solutions up through 100 gigahertz. As the markets move to higher frequency, which really is because people need higher data rates, and where you can get higher data rates is higher frequency. As these markets move to higher frequency, we have a lot of capabilities in microwave and mmWaves. And one of the great things about ADI is that we have capabilities in multiple technologies. So we have highly integrated silicon solutions, both CMOS and silicon germanium. We also operate in gallium arsenide and gallium nitride and have mmWave packaging capabilities. So we're able to integrate full signal chains, be they CMOS-based data converters all the way up through GaN PAs, and provide that optimal level of integration for these mmWave markets.
Yeah, it gives a lot of options to the customer, whatever they need, right?
That's right. And one of the things we found is that by being able to provide and select the right technologies and provide an optimal level of integration, we can usually give an increased value to our end customer and their end customer and how that performs in the end system.
So how about some of the specific markets? You guys are involved in the satellite market. How do you see the demand being driven in that market?
Yeah, so the satellite market is an area that we're focused on because it's really growing pretty quickly. And one of the key things about the satellite market is that this market's being driven by mobile data, just like all of these other markets, cellular, et cetera. And so the demands of this market are going up orders of magnitude. And so in order to be able to meet those customer demands for higher throughputs, 10 to 100 times higher throughput, to the user, no more cost, it really requires to have significant performance improvement and significant integration in the solutions that we deliver to our customers.
So as the frequencies go up, how does that affect the traditional markets that have normally been served?
So if you look at the satellite market, you know, if you look at the traditional bands, traditional satellite market is kind of the C-band and the KU band. And one of the challenges is that those frequency bands are highly saturated. If the satellite providers want to provide these higher 10, 100,000 times data rate increase that they're looking at, there's really no opportunity to do that there. So that's moving the market from KU band up to KA band. That's about a twice increase in frequency. The advantage of the KA band systems is that the Ka band is higher bandwidth, and also they use a different architecture for the satellite. So instead of having a broad coverage, they tend to have much narrower beams. This allows for much higher data rates in the Ka band. But what this means to the end user equipment is that at roughly twice the frequency, you need to have higher levels of performance in order to be able to support these higher data rates. And again, to an end user cost that is similar or even lower to what you have today. And so that drives to the integration conversation we had earlier. That drives, you need to really leverage these high performance, highly integrated technologies to be able to meet that level of performance.
So what kind of advantages are there then for cost reduction? Because, I mean, traditionally mmWave products have been very expensive, you know, waveguides, ceramic packages. How do you drive down the cost?
So I think the key thing on cost in this market is what's the cost to the end user. And if you look at dollars per bit in this market, is very similar to any of these broadband markets, is going down very rapidly. So, you know, you're looking at 10, 100 times the improvements on throughput for basically effectively the same cost to the end user. The keys to that, the only real way to get to those cost structures that when we sell to our customers, it's at the cost target that they need, is through these high levels of integration. So we have a lot of investments and capabilities in doing high levels of silicon integration for these Ka-band satellite solutions. So we're doing highly integrated kind of single chip transmit and receive solutions for this Ka-band market. These solutions have maybe 10 times or 100 times the throughput capabilities of previous generation solutions. They've integrated signal chains that are very discrete, that are multi-technologies into single chip solutions at board areas that are less than 10 times what you currently had, and maybe even in addition, a 30 to 40% power reduction. So if you look at that overall, we believe the way to get to the cost and performance that's needed in this market is through these high levels of integration.
Yeah, and you also have some unique packaging technologies that you use too that can help drive down the cost.
Exactly. So that's in addition to being able to operate in the optimum technology, be it silicon or gallium arsenide, gallium nitride. There's a lot of activity in surface mount millimeter wave packaging.
Right, yeah.
So if you look at what happened in the microwave market or at the microwave frequencies, when those markets went to surface mount, it really drove a much more mass adoption. We're bringing that same surface mount technology to these millimeter wave markets, to all the way up, say, up through 100 gigahertz.
Wow, impressive. So there are a lot of other markets that are involved in the millimeter wave products. Can you tell us about some of the other ones, point-to-point, VSAT?
Yeah, so I think what's great about, we look at the satellite market, for example, we believe there's a lot of growth, but there's also a lot of common themes in what's happening in the satellite market, to what's happening in the microwave radio backhaul market, to what's happening in automotive radar, or in the emergence of 5G. And all of these cases, these markets are all moving to higher frequencies because they all need higher data rates. If you look at microwave radio, for example, the only way to get higher data rate backhaul at a lower latency is to move to a higher frequency, and that's the emergence of E-band, which is millimeter wave. Automotive radar, which is a little bit different, but the only way to get high resolution is to move to wide bandwidth and get to higher frequency. That's happening at 77 gigahertz. Also 5G, they're talking about emergence at 28 or 32 gigahertz. So many of these markets have the same fundamental drivers, but in all of those cases, you really need to have an optimum technology integration. And a lot of the signal chain is being integrated in silicon, with then some of the front end of the silicon signal chain that's close to the antenna, be it power amplifiers, et cetera, in gallium arsenide or gallium nitride. And that's the capabilities that we're trying to bring. And we're trying to get leverage as we go after one market to leverage that technology across those markets.
Yeah, there's so many markets that are going to the higher frequencies, as you say, so it makes sense.
Yeah, and the other thing that's happening from a leverage perspective is many of them are going to phased array. So if you look at what 5G, they're talking about basically phased array solutions, multi-beam solutions, which, by the way, that's the same place that the satellite market is going with some of these new entrants. The new entrants that are talking about low Earth orbit satellites have a situation where the ground station needs to track the satellite as it goes through the sky. And those are basically going to multi-element phased array, which is very similar technology to what's happening in the 5G space, which is very similar technology to what's happening in the automotive radar.
And so another developing market that you're addressing is the new space market to bring internet to the rest of the world. How do you see that market shaping up, and what would be your participation in there?
Yeah, so if you look at the satellite market, we're excited about the traditional players because they are growing, they're launching new satellites, their markets are growing, their data rates are growing. But in addition to those traditional players, you have these new entrants that have kind of a radically new, very interesting business model. This business model is based on these low Earth orbit satellites. So the idea there is that the launch costs are much lower, so therefore you can launch more satellites, but they're at a much lower orbit. The technical challenge of that is those satellites at a low orbit, you have to track through the sky. And so that's driving this phased array technology. We're focused on developing that capability because, like I said, that phased array technology for these new entrants is the same phased array technology that is also being leveraged in 5G and automotive radar and other things like that.
Great. Well, all that makes sense, and thank you for giving you our perspectives today. We appreciate you being on the show. Thank you very much.
Thanks for having me.